Welcome to Nearpod Lesson 6.7 Stoichiometry, specifically mole ratios. So this is the title of your notes, and these are the 3 things you need to be able to do by the end of this video. So far in Unit 6, we've talked about chemical equations, how to predict products, and now we can figure out, okay, if I want to make a 500 milligram pill of something, how many of these ingredients or reactants will I need? We talked about balancing an equation to make sure that things match up before and after, right? And it happens to be that aspirin is pretty easy. So if I want to make specifically 1 mole of aspirin, C9H8O4, how much of this reactant will I need? Well, you might say, well, if I want to make 1 of this, I'm going to need 1 of these. So if I want to make 1 mole of this, I'm going to need 1 mole of these. Right, so basically it's like saying if the recipe calls for 1 of these molecules, I can make 1 of these. So if I need 1 dozen or 1 mole of these things, I can make 1 dozen or 1 mole of these things, assuming I have an endless supply of this other reactant or ingredients, right? So notice that basically what I'm writing is a ratio. So a mole ratio is kind of what I just wrote in the previous slide, and it is a conversion factor, or I can write it as a fraction or a ratio that compares or relates two substances in a chemical equation, and we use it to calculate different quantities of reactants or products needed, right? So mole ratio is kind of just the fancy chemistry term for saying, okay, if I want to double or triple a recipe, what do I need to do in terms of getting a certain number of reactants, right? So if I want to double the aspirin that I make, I'm just doubling my reactants or my ingredients here, right? But sometimes chemistry equations gets a little bit complicated, so I'm going to have to write mole ratios to help me out. So I can write mole ratios in 2 different ways, and we're specifically going to show them in 2 different ways in chemistry. So if I ask you what is the mole ratio between C7H6O3, this molecule, and C9H8O4, this molecule, can write it in 2 different ways, right? So we're going to write it as a fraction in chemistry, right? So I can either write it as C7H6O3 on top over this product called aspirin on the bottom, right? Or I can write it with 1 C9H8O4 on top over my reactants, right? One of these C7H6O3. So if I ask you what is the mole ratio between these two, well, for one of these, I'm going to need 1 of these. Or for one of the pink ones, I'm going to need 1 of the blue ones. Either of these could be the correct answer. What if I ask you what's the mole ratio between these two? Can you figure that out? So notice this molecule is this molecule. This molecule is this molecule. Go ahead and pause the video and unpause when you're ready, and I will reveal the answer. Okay, so you should have either guessed this one or this one. Again, my reactants are just 1. So my coefficient is always 1, so it's just a ratio of 1 to 1. One of these will get me one of these. If I have one of these things in pink, I'm going to make one of these things in purple.